Dear 9th grade students, hope to be fine and healthy. My name is Teacher Hala. We are going to learn a new lesson which is gases laws. We will start this lesson with very important question. Where does the pressure of gas come from? Where does the pressure of gas come from? Okay, we know before that any material consisted of tiny particles. In case of gas, the particles are very far apart. They are in constant random motion. Okay, the particles of gas are very far apart, so the attraction force between them is very low. In this case, the particles are in constant random motion. So the pressure of gas comes from the colliding with the walls of container. Okay, particles move randomly, so it can collide with the walls of container. This collision gives the gas its pressure. So the pressure of gas is due to the particles colliding with the walls of the container that gas is held in. This figure shows us a container filled with gas. The particles of gas move randomly, so it collides with the wall of container. The colliding with the wall of container, the gas particles exerting a pressure. So pressure of gas comes from colliding with the wall of container that the gas held in. This is a very important point. Understood? Now we will start with the first law of gases, which is Boyle's law. We have three factors that affecting the gas: pressure, volume, and temperature. Boyle's law linking pressure and volume at constant temperature. Okay, when we study relations between more than one quantity, we should study between two quantity only, or two quantity will be variable and third one will be constant. So we will study the relation between pressure and volume at constant temperature. Boyle's law states that for a fixed mass of a gas at constant temperature, same number of molecules at constant temperature, the volume of gas is inversely proportional to the pressure of gas. So what's meant by inversely proportionality? We said before, inversely proportionality means when the first quantity increases, the second quantity will decrease. Also in this case, when the pressure of gas increases, what happens to the volume? Yes, the volume will decrease. But when the pressure decreases, what happens to the volume? Yes, the volume will increase. So inversely proportional between pressure and gas and volume at constant temperature. The formula of Boyle's law. We said that pressure and volume are inversely proportional. To write this formula, it will be as P times V equal constant. P refers to pressure, V refers to volume. So P times V equal constant. Also, it can be written as P equal constant over V, or P1 V1 equal P2 V2. P1 V1 refers to the pressure and volume before impact. P2 V2 refers to the pressure and volume but after impact. So the formula of Boyle's law, P1 V1 equal P2 V2. When we draw the graphs as a relation between pressure and volume, we said inversely proportional between them. So when we draw pressure on y-axis, volume will be on x-axis. So we will get this curve. This curve means when volume increases, the pressure will decrease. When we convert the inversely proportional to directly proportional, we will draw the relation between P and 1 over V, pressure and 1 over volume. It gives us directly proportional between them. So we will get this straight line which starts from 0. So inversely proportional between pressure and volume, but directly proportional between pressure and 1 over volume. Understood? Now we will take some questions about Boyle's law. First question. A 500 milliliter can of gas is at a pressure of 20 kilopascal. Pressure of 20 kilopascal. Pascal here is the unit of pressure. Pressure has many units, same Pascal, atmosphere, and Newton per meter square. These are the units of pressure. Okay, if the can is run over by a garbage truck and flattened to a volume of 10 milliliter, so the volume was 500 milliliter and become 10 milliliter. The pressure was 20 kilopascal. He asked about the second pressure or the pressure after impact. In this case, to calculate the pressure, what will we do? We will use the formula of Boyle's law, which states that P1 V1 equal P2 V2. P1 refers to the pressure before impact, where the pressure is. It is equal 20 kilopascal times V1. V1 refers to the volume before impact. This volume equal 500 milliliter equal B2. Where is B2? B2 unknown. The pressure after impact unknown. Times V2, which equal 10. Okay, by calculator, 20 times 500 equal 10,000 equal 10 times B2. To get B2, what will we do? Yes, we will divide it over 10. So B2 equal 10,000 divided by 10. So B2 will equal 1000 kilopascal. See in this question, the first pressure was 20 kilopascal and the volume 500 milliliter. When the pressure become 1000, when the pressure increase, see what happened to the volume? The volume decrease. So it proves the inversely proportionality between pressure and volume. Second question. A sample of gas takes up 45 liters after being compressed down to a volume of 12 liters. The sample has a pressure of 5.7 atmosphere. What was the original pressure? In this case, he gave us the original volume and the volume and the pressure after impact. He asked about the original pressure or pressure before impact. Also, we will use Boyle's law, which states that P1 V1 equal P2 V2. But in this case, the original pressure unknown, P1 unknown, so we will write it P1 times V1, which equal 45, equal 12 times 5.7. So P1 times 45 equal 68.4. To get B1, we will divide it over 45. So B1 equal 68.4 divided by 45. So the original pressure was 1.52 atmosphere. Also, if you compare first pressure and first volume with second pressure and second volume, first pressure 1.52, first volume 45, second pressure 5.7. See, the pressure increase. So what happened to the volume? Yes, the volume increase. Hope to be fine and study well. Inshallah, see you next week. I want to thank Mr. Yunus about this chance. He gave us this chance to continue to still continue us in our syllabus. Thank you. Try to solve this homework. Any question, please send this on our website. Thank you, my students.